In this unit, we'll learn about a way to look at communication networks to try and solve network problems, and in general, organize all the information in a more orderly and convenient way. As we know, the communication network field is very broad and complicated and combines a large amount of components, such as end users, routers and various information lines, apps, protocols, hardware, software, etc. In order to understand the length and breadth of all these components, we need in-depth knowledge of math, probability and statistics, electricity, electronics, software development, physics, and many other related fields in this very broad field called communication networks. The question is whether there is a way to organize the needed information, at least in terms of the information we want to impart, comfortably and in an organized way in order to understand things, analyze, and maybe even solve problems in the field. The answer to this question is yes. The most convenient way we know today to deal with the complex systems in the field of communication networks is the layer model. The layer model divides this complex system into layers, so that each layer has a defined role or roles in the larger system. We can look at the model from the top down or from the bottom up, depending on the approach. The layer model allows dealing with identifying problematic points in the system, dynamics between parts of the system, and allows organizing the information conveniently. This model also allows improving and updating a specific layer without touching any of the other layers, because of the fact that even the improvement or behavior change of one layer still has an identical dynamics and behavior vis-a-vis other layers in the model. The first model we will study is called Internet Protocol Stack. This model looks at communication networks by dividing them into 5 layers. Each layer has different protocols which embody the layer goals differently, depending on demand. We'll look at this model from the top down. The application layer is a layer that provides services to the user. For example, FTP protocol, or File Transfer Protocol, is a protocol that allows file transfer between hosts. HTTP protocol, or the Hypertext Transfer Protocol, is a protocol for transmitting Internet pages objects, like pictures, video, sound, and more, between the website and the user's web browser. SMTP protocol, which allows sending and receiving email. There are many more different protocols which embody this layer. The transport layer is a layer responsible for transporting data between hosts. The hosts run local processes, and the processes don't have to talk to each other to create communication. This layer is responsible for the conversation of processes on the edges, and it is also responsible for communication reliability if it is required. TCP protocol provides communication reliability via a large number of internal mechanisms, whereas UDP protocol assumes that the line is sufficiently reliable for the service and therefore is not required to provide additional reliability. In general, when reliability is very important, for example in sending email, transferring files or web pages, we will prefer reliable communication with the trade-off of slight delays, and therefore use TCP. In communication where time is critical, so that extra delays may damage service, such as video conferencing, internet calls, streaming, and more, we will prefer UDP, which works faster because it's simpler, but does not provide the stability of TCP. The network layer is the layer responsible for routing the information between distant hosts. This layer is mostly responsible for finding a single route between the sender and receiver among all possible routes based on precisely defined parameters. This layer has additional roles beyond the defined ones which we'll learn about later. Routers, as we've learned in the previous units, belong to this layer because their job is to route data to its destination. The way to identify origin and destination hosts is via logical addresses, otherwise called IPs, Internet Protocol Address. In the following units, we'll learn how hosts and other devices get these addresses, how routers work with them, and how they're built. The link layer is the layer responsible for transmitting data between neighboring hosts, and there is a number of protocols supporting this role. The most familiar ones are Wi-Fi and Ethernet, and there are also other protocols which serve this layer. The physical layer is the layer responsible for the movement of electrons and bits on the links themselves. This layer requires various components, that is, various types of hardware, so that the bits themselves, which everything is made of, will get from place to place. Note that every layer requires the services of the layers underneath it to work. To demonstrate, we'll assume that a computer in country X sends a file to a computer in country Y. The application layer provides the file transfer service in this case, FTP, whereas the transport layer will provide communication reliability using TCP. The file will get to computer Y via a routing protocol which belongs to the network layer. The link layer will come into play during the process in the part between computers X and Y and the routers close to them. And without the physical layer, it would be infrastructurally impossible to transmit data between the hosts. The Internet Protocol stack misses out two important layers: the session layer, which is the conversion layer, and the presentation layer. The OSI, or the ISO model, covers both of these layers. OSI is short for Open System Interconnection. This model presents the various actions required in order to transfer data in the network and the order of these actions. The model looks at hardware, software, data transmission, and reception, and among other things, provides a general explanation on the various components of the network and on their various roles. The model was created by the International Standards Organization as a layer model with 7 layers, where every layer executes a specific part of the actions required for communication. Though this model was created for computer networks, it can easily be applied also for other communication methods, such as phone calls or sending letters via snail mail. So the OSI model consists of 7 layers. The role of each layer is to take care of the data created by the previous layer and the layer before that in order to be able to transmit this data to the other side of the communication. Processing on every layer includes analysis and classification of the data the previous layer added, and adding new technical data that will help the next layer to continue dealing with transferring the data to its destination. After the data got to the other side, the additions of the previous layers need to be decoded in order to reach the original information. In order for both sides to communicate, they usually work according to a pre-agreed protocol. To understand the process, we'll demonstrate working this model in the process of transmitting email. In the first stage, the user runs a program. For example, he types the name of a website in the browser address field. The connection model is the application layer. In the second stage, the application layer downloads the data to the presentation layer, which determines the method of data presentation, and sometimes compresses them, and sometimes encodes them. For example, this layer encodes the address of the website that was typed in, with some encoding. In the third stage, the presentation layer transfers the representation of the user's actions to the session layer. The session layer determines when it is possible to send a request to the bottom layers for full data transfer. In the fourth stage, the data goes from here to the transport layer. The layer sends the data according to the session protocol. This layer is responsible for creating the session. In the fifth stage, the network layer is responsible for the route the data takes until it reaches its destination. It gets the destination from the top layers. The sixth stage, the link layer, is responsible for transferring the collection of bytes received from the network layer to the next point on the way of the data to its destination. The layer will transfer to the physical layer bits that will make the information be read by the next communication point on its way to the destination. In the seventh stage, the physical layer translates bits of information into electric voltages or optic signals and transmits the data on a predefined wire. On the receiving end, all these actions are done in reverse. meaning that the physical layer receives the electric voltages or the optic signals and translates them into bytes and transfers them to the link layer. The link layer decodes the part of the message which is the address. If the address is the current point, the message goes on to the network layer. The network layer decodes more of the message. If the message concerns the action of the current point, the message goes on to the transport layer. If the message only has to go through this point, the message returns and is transmitted in the direction of its real destination. The transport layer checks whether this is the message that was expected in the conversation sequence with the other side. If it is, the message goes up to the session level. If it's not, a request for retransmission is sent to the network layer. The session layer synchronizes the message with the user application above it. The presentation layer extracts the compression, decodes encodings, and transmits data to the application layer in the form that the application requires. The application layer transfers the data and concepts as the desired website. Data transmitted online goes through a packing process called encapsulation. On the sender's side, every layer adds various control information to the data being transferred. And on the receiving end, this data is removed step by step. It is customary during encapsulation to name the data on different levels with different names. On the three top layers, the various protocols add an opener or end note to the data, which is called a data stream. In the transport layer, the data is divided into pieces called segments, so that their transmission online can be controlled. In the network layer, each segment is divided into chunks called packets. Each packet has the logical destination address attached to it. At the link layer, each packet has the physical destination address attached, and these packets are called frames. The physical layer deals only with the binary representation of the frames, which is why they are called a binary system. Note that since the router belongs to the network layer, it only works with the three bottom layers, whereas a switch belongs to the link layer, and therefore works with the two bottom layers. Further in this course, we'll learn precisely how routers and switches work. In this unit, we learned in depth about the layer model. We saw two main models: the 5-layer model, named Internet Protocol Stack Model, and the more detailed 7-layer model, which is called the OSI model, or Open System Interconnection Model.